Welcome, dear students. Today we'll be talking about finding the approximated value of the irrational number. By using the calculator, we can find the approximated value of each of the following. Like here, what is the approximated value of square root of 2? It's 1.4142. Square root of 3 is 1.73205. Square root of 5 is 2.236. The square root of 2 and the square root of 3 and the square root of 5 are called irrational numbers. Any irrational number lying between two rational numbers. In this example, the question is asking us to find two consecutive integers contain the number square root of 5. Two integers that they have square root of 5 in between. How can we do this? We put 5 between the two perfect square numbers 4 and 9. So, as you can see here, 4 is less than 5 and the 5 is less than 9. And we make a square root on the three numbers, square root of 4, square root of 5, and the square root of 9. So it will be 2 is less than the square root of 5 is less than 3. So the two consecutive integers that have square root of 5 in between are 2 and 3. Example number 2. Prove that square root of 3 lies between 1.7 and 1.8. How can we solve this? Every number of these three numbers we have, we're going to make it to the power of 2. So, square root of 3 to the power of 2 is 3. 1.7 to the power of 2 is 2.89. And 1.8 to the power of 2 is rounded to 3.24. Then, we're going to arrange them in an inequality. So, 2.89 is less than 3, and the 3 is less than 3.24. Then we're going to put a square root on the three numbers in this inequality. So square root of 2.89 is less than the square root of 3 is less than the square root of 3.24. Then square root of 2.89 is 1.7 less than the root 3 less than the 1.8. So here we have proved that the square root of 3 is between the 1.7 and the 1.8. Example 3, the question wants us to prove that the cubic root of 12 lies in between the 2.2 and the 2.3. We're going to do the same thing as the previous example, except instead of making to the power of 2 in the previous example, we're going to make it to the power of 3 to get rid of the cubic root of 12. Excellent. So, cubic root of 12 to the power of 3 is 12. 2.2 to the power of 3 is 10.648. 2.3 to the power of 2 is 12.167. Then, like the previous two examples, we're going to make an inequality. 10.648 is less than 12 is less than 12.167. After that, the question wants us to prove the cubic root of 12, so we're going to make a cubic root of the entire inequality. So cubic root on every one of these numbers. Then cubic root of 10.648 is the 2.2. Cubic root of 12 as it is, then it's 2.3. How can we represent the irrational numbers on a number line? As you can see here, to draw a line segment with length of square root of a length units where a is greater than 1. Draw a right angle triangle in which the length of one side of the right angles equals a minus 1 over 2 and the hypotenuse is a plus 1 over 2. How can we represent this on a number line? If the 7 is a, so we make 7 minus 1, which is 6 over 2, then it's 3, and 7 plus 1, which is 8 over 2, then it is 4, and the 7 plus 1 or the a plus 1 is the hypotenuse. This is how we represent it on a number line. Example 5. Find the side length and the diagonal length of a square whose area is 10 centimeters long. As long as the area is 10 centimeters long, then the side length is square root of 10. How can we find the side length and the diagonal? Yes, the diagonal is 2 times the area, so the diagonal is square root of 20 centimeters long. Let's now move on to the evaluation part. And as I always tell you, when it comes to the evaluation part, please pause the video, try to answer the questions yourself, then play the video again to check your answers. In this part of the evaluation, the question is asking us to choose the correct answer. Let's now see question number 1. The irrational numbers in the following numbers is, which of the following is an irrational number? So we need to go and simplify every one of the choices and check which one is an irrational number. Square root of 1 over 4 is? Yes, it's half. Cubic root of 8 is? It's 2, which is rational. Square root of 4 over 9 is 2 over 3, which is also rational. The square root of 2 is the irrational number that we have here. So the right answer of question 1 is choice D. Cubic root of negative 3 all to the power of 3. Excellent, as you guys said. The power of 3 cancels or crosses out the cubic root. So the result is negative 3, as we have it here in choice B. Question 3. The irrational number located between 2 and 3 is what? So, if we do it as the previous examples, we'll see that it's the square root of 7. Question 4. The irrational number located between negative 2 and negative 1 is what? For sure it is a negative number and it has to be irrational. So, choice A is not correct because it's rational. Choice B is not correct because it's rational. Choice D is not correct because it's not a negative number. Then choice C is the irrational number located between negative 2 and negative 1. Second part of the evaluation is the prove that part. Here in the prove that we have 2 questions. Let's answer the questions together. In question 1, it says square root of 2 is included between 1.4 and 1.5. The question wants us to prove that the square root of 2 is included between 1.4 and 1.5. So we're going to take every and each number of these numbers and make them to the power of 2. So this one to the power of 2 is 2. The 1.4 to the power of 2 is 1.96. The 1.5 to the power of 2 is 2.25. Then we're going to write the 1.96 is less than the 2, where the 2 is less than the 2.25. If I make a square root for the 3 numbers in the inequality, like this, the square root of 1.96 is 1.4, and here we have a square root of 2, and here we have the square root of 2.25 is the 1.5. Let's now move on to question 2. In question 2, take care, it's not a square root, it's a cubic root, right? So we're going to take every and each number of the 3 numbers that we have, and we're going to make every number to the power of 3. So, in question 2, cubic root of 2 to the power of 3 is 2, where 1.2 to the power of 3 is 1.728, and 1.3 to the power of 3 is 2.197. If we're going to write the inequality, 1.728 is less than the 2, and the 2 is less than the 2.197. If I make a cubic root for the three of them, so it will be cubic root of 2, and here it's cubic root of 2.197. Then the cubic root of this number is the 1.2 less than the cubic root of 2, which is less than the 1.3. So this proves that the cubic root of 2 is between the 1.2 and the 1.3. Dear students, by finishing this example, we came to the end of our lesson today. Thank you very much and best of luck.